morning, students. Using all the properties of the inverse trigo functions defined in the principal branches, we shall today solve questions from exercise 2.2. So the first question, where we have to prove that 3 sine inverse x is sine inverse 3x minus 4x cube x belongs to closed interval minus half to half. So here let us start with a substitution. Sine inverse x is theta. See, when you look at the right side of the question, now you see variables here. The moment you see variables, that means some kind of substitution is required. If we assume sine inverse x to be theta, then we can substitute x as sine theta. And here then the left hand side becomes 3 sine inverse x can be written as theta. So simplified form of left hand side is 3 theta. On the right hand side, sine inverse, substituting for x, it is 3 sine theta minus 4 sine cube theta. This is a result studied in class 11, and this is basically formula for sine 3 theta. Now we have done one important result in the properties of inverse trigo functions, that sine inverse of sine x will be equal to x only if x belongs to the principal branch of the sine inverse function, which is this. So here, how do we ensure that this angle belongs to the principal branch? So for this we will use this information here. The information can be written as x greater than equal to minus half less than equal to half. So let's replace x by sine theta. So x sine theta is greater than equal to minus half less than equal to half. Now before we proceed further, I'll just explain what is meant by increasing and decreasing trigonometric functions only in the first quadrant. So some angles that we already know, in specific angles in the first quadrant. So finding out here values of theta here, this is 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Values of cos theta would be, here we have defined angles only in first quadrant, including 0 and 90 degrees. So tan theta is 0. Cot theta can be written as then next let us take cosec theta. And then values of sec theta. So these are the values. Now if you look at the values, no, one thing you will notice that the angles, as we move from left to right, the angles are increasing. Alright, look at the sine function. It is increasing from 1 moving to 3's values. It goes to from 0 to 1. That means angle is increasing, value of sine function is increasing. That means the sine function is increasing function in the first quadrant. Look at cos theta. Angles are again increasing, but the value is decreasing from 1 to 0. So here we will say this is a decreasing function. Likewise, moving on to tan theta, value going from 0 to 1 to root 3. So this is increasing function. Look at values of cot theta, the value is root 3 and then it is decreasing to 0. So that means cot theta is a decreasing function in the first quadrant. Likewise for cosec theta, you can see value decreasing from 2 to 1. So this is a decreasing function. Cosec theta value is increasing from 1 to 2. So here this is an increasing function. So once again, if angles are increasing, the value of the trigonometric ratio is also increasing, then such ratios are increasing function. If the angles are increasing in the first quadrant and the corresponding value of the trigonometric function is reducing, that means that trigonometric function is a decreasing function. So you can see here that all the trigonometric ratios starting with C, cos theta, cot theta, cosec theta, these are all decreasing functions and the others are increasing functions. So this is one easier way to remember it. So now since we are dealing with sine theta, we know sine theta is an increasing function. If the value of sine theta is more than minus half, that means theta will also be more than sine inverse of minus half. Sine theta is less than half, that means theta will also be less than sine inverse half. Of course the equalities are there. Now finding out the principal value here, we know this value will be equal to minus pi by 6. This value will be equal to pi by 6. So what we get to know is that the angle theta lies in this range. Our angle is 3 theta. So multiply each component by 3. So the angle becomes 3 theta. Multiplying this by 3, we get minus pi by 2. And multiplying this by 3, we get pi by 2. So we get to know that this angle lies in the principal branch. Because it lies in the principal branch, so here we can write down that the result is 3 theta. So left side is 3 theta, the right side also is 3 theta, hence we have proved the result. So from here to here, we can write down only when we are sure that the angle belongs to the principal branch. And to decide this, whichever ratio we are using, we'll first see it is increasing function or a decreasing function in the first quadrant. So next, let's try out question number 2. Prove that 3 cos inverse x is equal to cos inverse 4x cube minus 3x when x belongs to the closed interval half to 1. So here again on the right side you see there are variables x, so we need some kind of substitution. So if we take cos inverse x is equal to theta, then we can substitute x as cos theta. Proceeding like we did in the previous question, left side is 3 cos inverse x, so it becomes 3 theta. On the right hand side, cos inverse, replacing x, 4 cos cube theta minus 3 cos theta. This is again formula for cos 3 theta. Now here the result will be equal to 3 theta if this angle belongs to the principal branch of the cos inverse function. Now to check this, let us use this information. X is greater than equal to half, less than equal to 1. X is cos theta, so that means cos theta is greater than equal to half, less than equal to 1. Here we know cos is a decreasing function, so if cos theta is greater than equal to half, theta will be less than equal to cos inverse half. If cos theta is less than equal to 1, then theta will be greater than equal to cos inverse 1. So here let us find out the principal value of cos inverse half, and cos inverse half is pi by 3 radians. Cos inverse 1 is 0. So this angle is theta. What we want is 3 theta. So multiplying each component by 3 theta by 3, we get here pi and here 0. So in this kind of an inequation, we usually write down the greater than component on the left hand side. So here I'll just rewrite it, 3 theta greater than equal to 0 and less than equal to pi. So we know that the angle 3 theta belongs to the principal branch of the cos inverse function. Hence this result can be written as 3 theta. Since the left hand side is equal to right hand side, hence we have proved this result. So you can compare the two equations, especially this part, and see where is the change in this question. This step and this step is important, because here, because the function is increasing function, so you can see the signs of the inequalities do not change. Here the important step is this and the next step. Because cos is a decreasing function, so here the inequality sign will change this way. This is what we have to always keep in mind. So next is question number 3. Prove that tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse half. Now in this case, this is something identical to tan inverse x plus tan inverse y. So let's write down the identity first. Tan inverse x plus tan inverse y will be equal to tan inverse x plus y upon 1 minus xy if xy is less than 1. So let us first check this condition, x and y. So here x is this, y is this. So product of x and y is 2 by 11 into 7 by 24. So here you don't need to multiply and write down the product. You can simply compare that in both the cases numerators are less than denominators. So the product will be less than 1. Since this condition is satisfied, that means we can use this formula. So the left hand side can be written as tan inverse x plus y upon 1 minus x into y. Here if any cancellation is possible, I am simply avoiding it, taking LCM and simplifying. So in the numerator we have 48 plus 77, and here we'll get 262 minus 264 minus 14, and this is equal to tan inverse 125 upon 250, which turns out to be tan inverse half, which is equal to the right hand side. So you have to remember to always check this result. If this condition is not satisfied, this identity cannot be used. Okay, next we are trying out here question number 5. Function is given tan inverse under root 1 plus x square minus 1 upon x. It is mentioned x is not 0 because if x is 0 here, this part will become the indeterminate form. So here let's call this function y. What are we trying to do here? We are trying to simplify the function. Once again, notice that you have variables here. The moment you have variables, that means you need some kind of substitution. So what kind of a substitution do you need? Trigonometric substitution. So x can be either sine theta, cos theta. It can be tan theta, cot theta. It can be sec theta, cosec theta. That means 6 substitutions are possible. Which one is applicable here? Let's see that. How do we find out that? Look into the square root term, and suppose we start with sine. X is sine theta. So 1 plus sine square theta, there is no formula. So we discard sine theta. Move on to the next substitution. cos theta. 1 plus cos square theta, no formula in trigonometry, so this option is also deleted. What is the next thing? X can be tan theta. 1 plus tan square theta, there is identity. That means x can be tan theta. Likewise, if we substitute x as cot theta, 1 plus cot square theta also gives us an identity. So two substitutions are possible. So x can be either tan theta or x can be cot theta. Right now I'm starting with x equal to tan theta. So let's see, what do we get? Tan inverse under root 1 plus tan square theta minus 1 upon tan theta, tan inverse. This is sec square theta under root sign, that means it can be modulus of sec theta minus 1 upon tan theta. Modulus of sec theta means that the function sec theta can be positive or negative. So we have to cross check, is it positive, negative. So you know the principal branch of the tan inverse function, here theta will be tan inverse x. So the principal branch of the tan inverse function is minus pi by 2 to pi by 2, and in this case, because we are dealing with a sec function, if you draw the graph of the sec function, it is like this. This value is plus 1, right? So you notice here that in this range, the value of the sec graph remains positive. So here we decide that it is tan inverse sec theta minus 1 upon tan theta. Now simplify this, substituting sec and tan in terms of sine and cos. So we shall be getting here 1 minus cos theta upon sine theta, because cos theta gets cancelled, and over here using trigonometric identities. Now these are important identities. You have to remember 1 minus cos theta can be written as 2 sine square theta by 2, and sine theta can be written as 2 sine theta by 2 cos theta by 2. So here this gets cancelled, one sine term gets cancelled. So finally in the simplified form we are getting tan inverse tan theta by 2. Now here this result will be equal to theta by 2 if this angle belongs to the principal branch. So now let's check. The principal branch of the tan inverse function is greater than minus pi by 2, less than pi by 2. That's the principal branch of the tan inverse function for an angle theta. Our angle is theta by 2, so multiply by half. So this becomes minus pi by 4, and this is positive pi by 4. This is a subset of the principal branch. So either the angle has to belong to the principal branch, or the angle should belong to a subset of the principal branch. Then this result can be written as theta by 2. Substitute theta from here, so our result is half tan inverse x. So that means a function of this kind in the simplified form is half tan inverse x. Here we have used the substitution x is equal to tan theta. One more substitution is possible. So now let's see, if we substitute cot theta, are we going to get the same result or not? Okay, for the same question, let x is equal to cot theta, so that theta is cot inverse x. So the function y is tan inverse under root 1 plus cot square theta minus 1 upon cot theta. Simplifying, 1 plus cot square is cosec square theta, square root gives us plus minus cosec theta, or you could have written modulus of cosec theta minus 1 upon cot theta. So the principal branch of the cot inverse x function is the open interval 0 to pi. So in the open interval 0 to pi, if we draw the graph of the cosec function, the cosec function graph is like this, alright. it's not drawn accurately. This value is positive 1. Fine. So you can see here in this interval the function acquires positive values. So here we decide that it has to be tan inverse cosec theta minus 1 upon cot theta. Once again, changing to sine and cos terms, this becomes 1 minus sine theta upon cos theta. Now here there is no direct formula for 1 minus sine theta, so we will have to convert sine theta into cos pi by 2 minus theta, because this gives us sine theta. Likewise, in the denominator, cos theta can be written as sine pi by 2 minus theta. Okay, and now solving it further, this is tan inverse. So 1 minus cos theta gives us 2 sine square half of this angle, so the angle is pi by 4 minus theta by 2. Likewise, sine 2 theta can be written as 2 sine half the angle pi by 4 minus theta by 2 cos pi by 4 minus theta by 2. Okay, so it's the same formula, 1 minus cos theta upon sine theta. We are just taking care of the angles. So 2 gets cancelled, 1 sine term gets cancelled. So finally we have tan inverse of tan pi by 4 minus theta by 2. So here again we'll have to cross check that this angle either belongs to the principal branch of the tan inverse function or a subset of the tan inverse function. So for that, let us again see here that the principal branch of the tan inverse function is this. You want an angle minus theta by 2, so multiplying this in equation by minus 1 by 2. Now when you are multiplying by a negative term, this sign will change, greater than becomes less than, multiplying by minus half, you get pi by 4. Again this sign less than will change into greater than, multiplying by minus half, we get this. Now you want pi by 4, so add pi by 4 to each component. So pi by 4 minus theta by 2, adding pi by 4, we get pi by 2. Here adding pi by 4, we get 0. So just rewriting it the other way, where we write down the greater than component on the left side and the less than component here. So this tells us that the given angle belongs to a subset of the principal branch. Hence, this result can be written as pi by 4 minus theta by 2. So now I'll just erase this part and explain you what is the simplified value of this expression. So what we are getting here is value of y is pi by 4 minus theta by 2, where we know that theta is cot inverse x. This result and this result are both are same. How is this possible? Let's check on this. Cot inverse. We are replacing cot inverse by pi by 2 minus tan inverse x. The identity which we have used here is tan inverse x plus cot inverse x equal to pi by 2 for all real numbers. So that way cot inverse x is pi by 2 minus tan inverse x. And simplifying, these two terms get cancelled. Our result is half tan inverse x, which is same as this. So that means in questions where two substitutions are possible, you will get the same result, half tan inverse x. After a little bit of simplification, you will again get half tan inverse x. So next we are trying out here question number 6. Y is tan inverse 1 upon under root x square minus 1 mod x is greater than 1. So what does mod x greater than 1 means? Mod x greater than 1 basically means that x is greater than 1 or x is less than minus 1. So here again we have to decide what is a possible substitution of x. So sine cannot be sine cos, it cannot be tan and cot, it can be sec and cosec. Okay, so suppose we are taking here cosec theta. So we know theta is cosec inverse x. So substituting this value, tan inverse 1 upon x square, that is cosec square theta minus 1, and cosec square theta minus 1 is cot theta, and under root of cot theta can be plus minus cot theta. So it can be plus minus cot theta, so that means it can be tan inverse plus minus tan theta. Instead of plus minus sign, you can write down modulus of tan theta, or this can be written as tan inverse tan theta, or it can be written as tan inverse tan minus theta, because we know tan minus theta is minus tan theta. So the result can be written this way. And how do we proceed further? This result will be equal to theta if and the value of theta is greater than 0 and less than pi by 2, and it will be negative theta whenever theta is greater than minus pi by 2 and less than 0. Now you know, for the tan inverse function, the principal branch is defined as the open interval minus pi by 2 to plus pi by 2, which means the first and the fourth quadrant. We know the angle will be positive in the first quadrant and negative in the fourth quadrant. So here, if the angle is positive, we know it has to be in the first quadrant, so we have defined the angle like this. And here the angle is negative, that means it has to be minus theta. So here, replacing what is theta? Theta is cosec inverse x. So rewriting the result here, theta is cosec inverse x, and here it is minus cosec inverse x. Where? In which category? So for that, let us look into the graph of the cosec inverse function. Okay, the graph of the cosec, I'll look into the graph of the cosec function. So we are defining angles from say minus pi by 2 to pi by 2, and the cosec graph goes like this, and it goes like this till pi, and here it goes this way till minus pi. Okay, so you can see here that whenever x is greater than positive 1, the value will be positive. So here, for cosec inverse function, we can write down x is greater than 1. And over here, I've drawn it over here. This value is actually on the y-axis minus 1. Graph is not accurately drawn. So here you can see when for values less than minus 1, the function will be negative. So here we write down x less than minus 1. So that means the function tan inverse 1 upon square root of x square minus 1 can be simplified to cosec inverse x whenever x is greater than 1, or it can be minus cosec inverse x whenever x is less than 1. I have drawn here graph of the cosec function. The same concept can be understood looking at the graph of the cosec inverse function. So next, let's try a question number 7. Y is tan inverse under root 1 minus cos x upon 1 plus cos x, when x is greater than 0, less than pi. Now in this question, this is a trigonometric ratio here. X is not just a variable here, it is associated with a trigonometric ratio, so we don't need a substitution here. Using trigonometric identities, 1 minus cos x will be 2 sine square x by 2. 1 plus cos x is 2 cos square half of the angle, so this gets cancelled, and you have here under root of tan square x by 2, which you can write down as tan inverse of tan x by 2. Here again this value will be equal to x by 2 if this falls in the principal branch or a subset of it. So here we are given a condition, x is greater than 0, less than pi. Our angle is x by 2. So let us take x by 2, dividing by 2, 0, here is pi by 2. So you know our angle basically belongs to the first quadrant, hence the value will be positive x by 2 only. So a function of this kind reduces to x by 2 in the simplified form. So next is question number 8. Y is equal to tan inverse cos x minus sin x upon cos x plus sin x, where we are given x is greater than minus pi by 4 and less than 3 pi by 4. Here again you can see we have got trigonometric ratios, so simplify dividing numerator and denominator by cos function, so we get 1 minus tan x upon 1 plus tan x, and this 1 can be replaced as tan pi by 4 minus tan x in the numerator. Denominator we are writing 1 plus, this I am writing as 1 into tan x, and that 1 is being replaced by tan pi by 4 into tan x. So if the same expression is written like this, then we can use an identity tan inverse tan pi by 4 minus x. Now this result will be pi by 4 minus x if this angle belongs to the principal branch of tan inverse function or a subset of it. Let us check. This is what we are given. What we need is minus x. So first we are multiplying the equation by minus x. The sign will change. Multiplying by minus 1 we get positive pi by 4. This sign will change. Multiplying by minus 1 we get this. Next add pi by 4 to it. So pi by 4 minus x. On this side pi by 4 plus pi by 4. On the right hand side minus 3 pi by 4 plus pi by 4. So we have added pi by 4 in all these parts. So we get this is less than pi by 2, and this is greater than, on simplifying we get minus pi by 2, writing it in the right order where the greater than part is written on the left hand side, less than pi by 2. So you notice that this angle lies in the principal branch of the tan inverse function, hence this result can be written as pi by 4 minus x. So this complicated function in the simplified form becomes pi by 4 minus x. So next we are trying 10th question. Y is equal to tan inverse 3a square x minus x cube upon a cube minus 3ax square, where a is greater than 0 and x is greater than minus a by root 3 less than positive a by root 3. So you can see here x is a variable, that means x has to be needs some substitution. There is also a constant a here, so it has to be a times some trigonometric function. So let us substitute x as a tan theta. Now why are we using this substitution? This will be clear in 2 steps. So let us substitute it first. We get 3a cube tan theta minus a cube tan cube theta. denominator a cube minus 3 a cube tan square theta. Now because in the question we are given that a is greater than 0, so a positive quantity can be cancelled off easily, and we have here, taking a cube common from numerator and denominator, 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So this is basically the identity of tan 3 theta. So in order to use this identity, we have used this kind of a substitution. If you simplify further, you get x upon a is tan theta, and from here we can easily find out theta. So now we'll check whether this angle belongs to the principal branch or a subset of it. So from here, x we are substituting as a tan theta greater than minus a by root 3 less than a by root 3. A is a positive quantity, so can be cancelled off, and we get tan theta greater than minus 1 by root 3 less than 1 by root 3. Because tan theta is an increasing function, so these signs of the inequalities do not change, and we get theta is greater than tan inverse minus 1 by root 3 less than tan inverse 1 by root 3. Calculating the principal branches, this angle is minus pi by 6, and here it is pi by 6. This is for angle theta, our angle is 3 theta. So multiplying by 3 theta, we are able to get the angle in the principal branch. Hence, this value is equal to 3 theta. Substitute theta. What is theta here? Tan inverse x by a. So a complicated function of this kind can be simplified to this form. So next we are trying here question number 12. Find the value of this cot tan inverse a plus cot inverse a. Now we know here that tan inverse x plus cot inverse x for all real numbers will be equal to pi by 2. So cot of pi by 2 is what we have to find out, and this value is equal to 0. These are all 1 mark questions. Then 14th question. If sine inverse 1 by 5 plus cos inverse x is equal to 1, then we are required to find out x. So the equation can be rewritten as sine inverse 1 by 5 plus cos inverse x is sine inverse 1, and we know sine inverse 1 is pi by 2. So we get a function like this: sine inverse plus cos inverse is pi by 2. Now we are also familiar with this result. Sine inverse x plus cos inverse x is pi by 2 whenever x belongs to this range, this closed interval. So you can see here x belongs to 1 by 5 belongs to this category, and hence we know this. Comparing these two results, we get to know that x has to be equal to 1 by 5. So next we will take up question number 15. Tan inverse x minus 1 upon x minus 2 plus tan inverse x plus 1 upon x plus 2 is pi by 4. So here we are finding out value of x. So this is just like tan inverse x plus tan inverse y. So using that identity, we can write down tan inverse plus y upon 1 minus x into y, which is equal to pi by 4. So let us simplify this bracket first. So here I shall be getting x minus 1, x plus 2 plus x plus 1 into x minus 2, and in the denominator it should be x square minus 4 minus x square minus 1. So this is the simplified form of the terms in the bracket, and this tan inverse function is shifted to the right side, it becomes tan. So here multiplying we get x square plus 2x minus x minus 2 plus x square minus 2x plus x minus 2 upon x square minus 4 minus x square plus 1, which is equal to 1. So certain terms get cancelled, plus 2x minus 2x plus x minus x. So numerator gives us 2x square minus 4, and the denominator gives us minus 3. So we are getting 2x square minus 4 is equal to minus 3, and 2x square is minus 3 plus 4, hence x square is 1 by 2, therefore x is equal to plus minus 1 by root 2. So we are getting two values of x. Now we will cross check, are both values possible or not, because we can't leave the solution here. How do we check that? We have used this identity, tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. Now this result can be used only when x, y is less than 1. So let us find out product of x and y. So this is x and y, alright, the left hand side. So we get x square minus 1 upon x square minus 4. In this case, if we substitute 1 by root 2 positive or negative, the square term will give us positive result only. So substituting any value, we will get here 1 by 2 minus 1 upon 1 by 2 minus 4, which if simplified gives us minus half, and this is minus 7 by 2, which turns out to be 1 by 7, and that is less than 1. So because xy is coming out to be less than 1, that means both values are possible. So next we have few 1 mark questions. Find the value of sine inverse sine 2 pi by 3. Now we have done one result which tells us that sine inverse sine x will be equal to x if x belongs to the principal branch of the sine inverse function. So here if we write down 2 pi by 3, then we notice that this angle is basically 120 degrees, and 120 degrees does not belong to the principal branch. So how do we simplify this? So sine 2 pi by 3 can be written as sine pi minus pi by 3. Using standard results of trigonometry, sine pi minus theta, in the second quadrant sine ratio is positive, so it will become sine pi by 3. Now if you write it down as pi by 360 degree, then this angle definitely belongs to the principal branch of the sine inverse function. So these kinds of questions where some students usually write down this as the answer, have to be careful. Check whether the angle belongs to the principal branch or not. So this is the right result. Then next, question number 17. Find out value of tan inverse tan 3 pi by 4. Okay, here again we know that the principal branch of the tan inverse pi by 4, if suppose we write down this value as 3 pi by 4, then does this value belong to the principal branch of the tan inverse function? This is 135 degree, which does not fall here. So once again it is not 3 pi by 4. How do we modify it? So modifying, I can write it down as tan pi minus pi by 4, second quadrant, tan function will become negative, so it will be minus tan pi by 4, and this can be written as tan minus pi by 4. We know tan minus pi by 4 is same as minus tan pi by 4. Now here if we write this angle as minus pi by 4, this angle belongs to the principal branch of the tan inverse function. So tan inverse tan 3 pi by 4 has a value minus pi by 4. Next we'll try your question number 19. Value of cos inverse cos 7 pi by 6. So in this question, if you once again write it down as 7 pi by 6, which is 210 degrees, this does not belong to the principal branch of the cos inverse function. So again some kind of modification is required. So because this angle is in the third quadrant, we can write it down as pi plus pi by 6, and in the third quadrant the cos ratio is negative, so it should be minus cos pi by 6, and we know this result, cos inverse minus x can be written as pi minus cos inverse x as long as x belongs to this category. So here using the same result, cos inverse minus x. So over there, so using this result, cos inverse minus x, this is the value of x, cos inverse minus x. This should be equal to pi minus cos inverse x, and cos inverse x is cos inverse x, and x is cos pi by 6. So pi minus this result can be written as pi by 6 because pi by 6 belongs to the principal branch, and further simplifying we have the angle 5 pi by 6. This 5 pi by 6 means 150 degrees, and this belongs to the principal branch of the cos inverse function. So this way we have first converted, because this angle is in the third quadrant, we have written it as pi plus pi by 6, which turns out to be minus cos pi by 6. So using this identity, cos inverse of minus x, which is pi minus cos inverse x, we have simplified this result. So pi minus cos inverse x, this is now equal to pi by 6. Further simplifying 5 pi by 6, this angle belongs to the principal branch of the cos inverse function. So with this question we have attempted almost all important questions of the exercise, and this will help you to solve the remaining questions of the exercise.